So welcome to the Node.js Node API team meeting for June 25th, 2021. We will follow our standard approach of looking through the issues that we've tagged for milestone 11. It's been a very long milestone, but anyway. Before we get started, does anybody announcements or news that they'd like to share? Doesn't look like we have anything to share there, so I will share my screen with the milestone 11 and we can go from there. The first issue is stale issues in Node.API to discuss. So the first one there, taking a quick look, I think the only one there is still 912.
Yeah, I got a few updates.
Okay.
So currently we are referencing the JavaScript values in the NLP error. So in that case, we can only reference objects. Most of the native primitive values in JavaScript, we can fetch the net value and keep a reference by value in the native side, but that's not the case for the symbol. So I have raised a issue in Node.js core. It's but in the bottom, there is also a TC39 proposal which is stage 2. They are proposing that losing the on the weak maps so that we can use symbols as weak map keys, so that we can check on those symbols to, let's say, if they are get GC'd, and if they get GC'd, we can get a somewhat callback, but however, that's not the weak map case. But I believe the situation is very similar. We are going to, like, say, allowing symbols to be referenced in the case. So I'm proposing that so that we can reference the symbol values, so we can keep all these JavaScript values in check with the NLP error object in current situation without introducing any breaking change.
Actually, correct me if I'm wrong, but an error in like the NAPI namespace, an error is a reference, right? A persistent reference. So
yeah.
If we used weak maps, well, we could actually just use a regular object then to store these errors, because the object would be a persistent, we would have a persistent reference to the object, right? We store the error we store the error as a property, just a plain old property of the object, right? And then since we have a persistent reference to the object, then the error, which is a primitive value, will reside on the object persistently and will not be garbage collected. And so if the user wants to retrieve the error later, then we can give it to them just by accessing a property, just by accessing this magic property on the object, right?
I'm sorry, but my explanation might not be very clear. What I mean is not using weak maps in the case, but it's we are still referencing the JavaScript value by the NLP reference. But for the primitive values, we are fetching the native value, like say double or integers, to store them by value, but rather than by reference, so that we don't have to create any NLP reference for it. So the key point for the using an object for those symbol or other primitive value in the NLP error object is that we must not create any calls into JavaScript for the case, since, like say, when we are finalizing, there is a disallow JavaScript execution scope in the Node.js core, so that any object set will not work in that case, and it will still abort. So we must not introduce any JavaScript codes in this case. So we have to, like say, use the V8's native methods to creating the reference or fetching the value. So I'm like saying that since we cannot fetch symbols as native value, and that's the case, we cannot handling with current Node API. So I'm proposing that we can loosen the NAPI created reference API to allow symbols to be create reference for symbol values. And
oh, you mean in core?
Yeah. Yes.
Oh, I see. I see.
So
yeah, honestly, when we defined the reference API, we did it with this restriction for objects, for JavaScript objects only, if I remember correctly, because Chakra Core didn't have support for creating references for primitive types. But every other engine that I've encountered, you can create a persistent reference to pretty much any JavaScript value, primitive or otherwise. So
yeah.
And now that Chakra Core is no longer on the horizon, I don't know whether it makes sense to retain this restriction.
Would we expect, like you said, all other JavaScript engines were able to do it? It's kind of like we don't want to preclude other implementations.
No, I know, but I don't think we are.
Yeah, so you think really Chakra was the outlier on that front? I
believe so. Yeah. I mean, okay, look, I haven't tested every last JavaScript engine, obviously, so I cannot speak for all of them. But I mean, obviously, I've done extensive work with V8 and JavaScript, and both of them have absolutely no issues making persistent references to primitive values. So
what I mean is that in TC39 we have to, since there is a proposal that we allowing symbols as weak map keys. So in that case, in any way, the symbols have to be able to be, like say, referenced in the case. So if that is the case, the engines have to support the symbols to be referenced.
Yes and no, right? Like it's one thing to be like, I believe those may be two different kinds of references, right? Like Chakra Core obviously supports references to primitive symbols, because if I store a primitive symbol in a variable, right, or if I store a primitive, or if I store like a string, let's say, if I store it on an object, right, then Chakra Core is going to keep a reference to that string as long as it's set as the property of an object. Right? That is one kind of reference. That is a reference inside the engine. The kind of reference I'm talking about is the kind that has like a native interface, right? That is not an implicit reference. It's an explicit reference made by native code, right? And that I think is a different kind of reference. And for some strange reason, Chakra Core did not have support for making references from native code to JavaScript primitives, but obviously it had to have support for making references to any JavaScript value, because JavaScript internally uses references to things, right? So that it doesn't garbage collect stuff as long as it has references. So Chakra Core obviously supported that, right? And so I believe that the references that are being talked about in this TC39 stage 2 proposal is not the same kind of reference that we're talking about, right? References from native code. They're talking about, making the way the JavaScript engine behaves, changing the way the JavaScript engine behaves to accommodate this, right? So those are two different kinds of references. And I don't know that this proposal would help us in the sense that it's going to force anybody to change the native interface. They don't really care about the native interface at TC39, right? That's my understanding, at least.
Yeah, but I was thinking that if that's allowed in the, let's say, weak map, then the disallowing any value other than the object in the native side won't make many sense.
Okay, I didn't. You cut out between makes and sense. There was a word in between that I caught, and it's a very important word. Can you please repeat that?
And what I was thinking is that in Node API, we have to match the language standard so that we don't expose too many things out or too many things to few things that don't allow people to do works that can be done in native JavaScript. So if the T39 proposal that allowing symbols to be, like say, referenced, so in Node API interface, we can match that semantics and
Yep. What I'm saying is what I'm saying is the TC39 proposal is well, no, let me start again. So what we have right now in Node API is actually an artificial restriction on what the engine exposed, because if you think about it, creating a reference is something the engine does all the time, right? It creates a reference to the number 5. It creates a reference to the string hello world. It does that all the time. Every time you assign something to a variable, the JavaScript engine creates a reference, right? And every engine that we've encountered so far, that I've encountered so far, except for Chakra Core, was able to unify the API that it uses when somebody writes a equals 5 with the API that the native programmer uses when they write, what is that? New reference, right? So only Chakra Core was. So Chakra Core was the only engine that made a distinction between the native JavaScript way of creating references, of telling the engine to create a reference, and the native C++ or C or machine code way of telling the engine to make a reference, right? So Chakra Core was quote unquote broken in that sense, because it didn't allow you to do the same things from the native side that you could do from the JavaScript side. Every other engine allows you to do the same things from the native side that you can from the JavaScript side. That is, create references to anything. You see what I mean? So now that Chakra Core is out of the picture, we might want to relax our requirements for what can be requested as a persistent reference. And then we don't need any proposal. The proposal doesn't strengthen our case. It's orthogonal to our case, is what I'm saying. Because the JavaScript engine internally already has support for creating references to primitive values, because it has to, in order for those values not to be, in order for you set a equals 5 and all of a sudden a is undefined because 5 was garbage collected, right? No, that doesn't happen in a JavaScript engine, right? So we already have the ability to create references to anything. It's just that we haven't chosen to expose that ability to our users because we were worried that Chakra Core might not be able to keep up. And in fact, it wasn't able to keep up.
Do we know if SpiderMonkey does that?
We don't. We don't.
Maybe it would be worth just testing it against that one, and maybe even the Apple one.
Yeah. I think it's our friends at Microsoft who have like this Babylon native going on and all that. They might be the people to contact on this, because they probably have more experience with more engines than any of us here, having done that work with Babylon native. So then we would have like a definitive answer to that.
That would be, so maybe go ahead.
I mean, we could look at the documentation at the native APIs for those various engines, and they would have to have some way of creating references, and there we could read whether they have restrictions on what kinds of references they can create. That's weaker than actually trying to create the reference and seeing if it fails or succeeds, but it's a
I'm more like, if the doc does, if we can't find how the doc tells us we think to do it, then the doc's worth looking at. Like, if the doc makes it clear you can, And those others, I think that's just a sniff test that would be worthwhile.
Yeah, true,
doing
true.
Before relaxing. Yeah. Now, the other proposal here is simply that we store them without a reference, right?
Yeah, and then you have to use them before the stack unwinds. Yeah.
Do you have to use them? Like, I think so. I guess Legendcast, you said we fetch them when they're later requested, right?
For the primitive values only.
Yeah.
We cannot store the object or functions.
Right, but I don't think we would be storing them, like leaving them on the stack though. Like we'd be storing them in native memory somehow, which was associated with the exception. Is that right?
Yeah. I mean, chances are you will process if you're asking for an exception, chances are you would process it before you return control to node.js and therefore to the engine, right? So yes, we could store the NAPI value itself without creating any sort of reference to it. But then if you want to store it in a variable, and then the call which caused the exception ends, control returns to JavaScript, and then later you end up calling some other API, and then you retrieve that NAPI value. That may or may not be
right. I don't think the suggestion was to store the NAPI value, but to actually grab the primitive value. Because they're primitives, we can store them in C code.
Oh,
right?
I see. Okay. So marshal them to native and then marshal them back to JavaScript. Okay. I see. Oh, I see. So, well, yeah. That's not bad.
Yeah, it seems like that seems reasonable, as long as like there's no gotchas in terms of memory lifespan or something that we would end up leaking memory. But
no, we'd be in control of the memory at that point.
Right.
I thought, how would you be able to marshal the symbol type?
Well, I think that's the one that Legendcast says that's the remaining problem.
Oh,
right?
I see.
Right.
Okay.
Yeah.
Okay.
Right, like
That's
all
the
the other
problem.
primitives you can marshal, no problem. Symbol we're stuck on.
Yeah,
right?
like if I were to throw a symbol.
There's no way to do that, right? Like
right.
Yeah.
Yeah, but still, like, so basically, I don't think this proposal will change the native API and the capabilities of the engine. It may be likely that there may be a probability that it might, but like I said, the engine already has the capability, like the engine we're working with here, and probably most other JavaScript engines, but we'd have to check the docs, already have the capability of creating persistent references to any and all types, primitive or otherwise, right? So we wouldn't even have to go through the marshalling step. And if you relax it for one type, you might as well just drop the constraint altogether, because as far as I know, there is no difference between symbols, strings, integers, floating point values, anything else in the engine.
In some engines, there are differences. Like say in JavaScript, they store small integers, just like say in the.
Oh yeah. In the pointer itself, yeah.
Yes.
Right.
Yes.
Right. Okay. But I mean, in that sense, they do the reference counting. Like if you store the integer 5 in a pointer, right, then no other JavaScript value in the entire engine will evaluate to 5, right?
Sorry, what do you mean?
So if you store the integer 5, right, as a Jerry value, right, then no matter what other Jerry value you create, right, whether it's a string or another integer 5 or something like that, it will never receive the pointer value 5, right? So like let's say I have the integer 5, and then I have an object, right? If I print the Jerry value t for that object, it will never be 5. It will always be something else, right? So basically, the integer 5 in JavaScript is at once an NAPI value. If you were to implement an API, it's at once an NAPI value. It is also at once a persistent reference to the value 5, right? It's both. So then, you know, you can just treat it as an NAPI reference. You don't have to do any work to treat it as an NAPI reference, right?
Right. I guess I don't quite understand how that, like, it's the, like, so if you had a second 5 though, which is still a primitive value,
it would just be like the primitive value 5. Again, it would be a pointer, which when printed out as a decimal would be 5. So then it's basically the same pointer, right? Because you can copy by value. So
there are value storing.
Yeah. So that kind of works.
Yeah, I mean, it will work, but I was saying that if the engine, like say, don't exposing the symbols. I mean, what I would mean is actually, ultimately is saying that if we didn't get to the stage to reference all of the value types, then the minimum requirement in that case will be allowing the symbol value to be referenced. So that's the minimum requirement for the case. So if we can get all of the value type to be referenced, well, then that will resolve all of the problem.
Yeah, so, exactly. And I think I think all of our problems are already resolved, because we just have chosen not to use the solution because of Chakra Core. That's what I'm saying.
So you're basically thinking if we changed our thing that said create reference to avoid a check that says, is this a primitive, it would just work.
Yeah, I believe it would, yes.
And it would work for symbols as well as everything else.
Yeah, exactly. Yeah, I'm pretty sure. It would definitely work in V8, and I'm pretty sure it would work in JavaScript as well, because in JavaScript you can just like, you basically you have to release a value unless you're using it. So in JavaScript, pretty much everything is a persistent reference. Like if you get a value from JavaScript, you have to afterwards explicitly release it. So basically the difference between an NAPI value and an NAPI reference in JavaScript is that in the case of an NAPI reference, you simply omit the step where you release the value until somebody explicitly deletes the reference. So yeah. Now, one thing that I don't remember anymore about JavaScript is how do you do weak references? Okay, they have a function pointer.
They implemented the handle scope in the JavaScript, so every NAPI value returned to passed to the userland side will be automatically dereferenced by the handle scope.
Yeah. Okay. Yeah. There's Right. Okay. Yes. Yeah. It will release our reference to the value, but what about like being? I know that JavaScript has a function pointer you can give it, and then it informs you, hey, listen, I want to garbage collect this value, so you know, you better do whatever you were gonna do. And I think that works for primitive values as well, right? But we should double check, because if weak references don't work for primitive values in JavaScript, then
actually, if the value is primitive value and they are stored by value, then there is no need for reference. The referencing is a no OP for the store by value, like say small integers.
Okay, but then a reference to a primitive value, let's say to an integer, in JavaScript is always a persistent reference. You can never make it a weak reference, right? You cannot say
it's by value, so the reference is not, like say, very makes sense in that semantics.
Yeah. The value will never be garbage collected, right?
Yes, you are using it by value. So if you release it, then the value is gone.
Well, but is it though? Right? Because you know the correct me if I'm wrong. The engine reserves the pointer, you know, 0x000005. It reserves that pointer. It never uses that pointer for anything except the integer 5, whether there are any integers 5 present in the JavaScript code or not. that pointer is always a valid value.
It's always a value. So you are holding your copy of the integer file in the pointer. So if you release the pointer, then your copy is gone. But the other copies in the JavaScript will still stored by value. So their file integer is still there, and so there is nothing like say reference in the small integer case.
Right. Okay. So let me ask you this. Okay, if I'm writing some code and I call JavaScript, right? Can I just say like, let's say set value on an object, right? I will not say Jerry create integer. I will just say, Jerry set value object comma bracket or cast to Jerry value t close bracket 5. Will that work or will that crash?
It will work, especially for the case of null p-value, or when the null p-value is null. The null is interpreted as undefined. It is interpreted as 0. Integer 0.
Right, exactly. So then in this case, it makes no sense to have a weak reference to the value 5, right? Because it's not a weak reference, because it's just the value itself. It is not garbage collected, because it's always a copy. It's never an object that is referenced or not referenced. It's always just a value, right?
Exactly.
So then if you expect somebody to call the weak callback on the primitive value 5, that will never be called, right?
Yes,
because
it's
just exactly. So this is a peculiarity of JavaScript. Like in V8, if I first of all, in V8 I cannot say set property and then bracket 5. I can't do that. I can't cast the number 5 to a local value. If I do that, V8 will crash, because you have to explicitly create the number 5, right? And then second, and because of that, if I create a persistent reference to the number 5, that is a true persistent or a weak reference, depending on what I want. That is a true weak or a true persistent reference. And so if it is a weak reference, the weak callback will eventually be called when the number 5 goes out of scope everywhere and is ready to be garbage collected. So this is a difference in behavior between JavaScript and V8. But this difference in behavior exists whether we use an API or not. And I don't think we can pretend to, we can't make it work the same way for both engines. It's just not possible.
I guess my concern is like, if like say this, our API, I think, lets us create strong or weak references, right?
Yeah.
Can we get into the case where people are asking for weak references? Like today, today it wouldn't matter because you can't ask for references at all on those, right?
Right.
Can you ask for a weak reference and say, hey, I want to go through the entire integer set, just because like I'm doing it on random numbers, and you're eventually still consuming memory, right? Does it effectively consume memory or not? I guess is the
in JavaScript it effectively doesn't, because in JavaScript the value of the pointer becomes the location it points to. So the value of the pointer and the location it points to are the same thing in JavaScript, right? In V8 they are not. In V8 the location is something precious that is to be referred to by different pointers.
If I've used 5, does that prevent me from using a pointer to 5 for something else? If I've used it in that way, I'm still thinking it uses up some resources if I versus if I hadn't used it at all, right?
Yeah, but the way JavaScript processes pointers is that it would treat pointers below a certain value as not pointers but values. So it does an implicit pointer dereference, if you want to look at it that way.
So basically it consumes that no matter what.
Yeah, exactly. Yeah. So
doesn't matter whether you okay.
Yeah, it's a really sort of a weird thing, but sometimes it's a pointer, sometimes it's the value itself. That's what's weird about JavaScript.
But basically, whether I use an integer or not, JavaScript is basically using address space, not necessarily memory mapped into it, but
well,
like using address space it's consuming address space that you can now not use for something else.
yeah, you can think of it that way. Like the pointer with the value 5 is always pointing to something that is, you know, hard coded into JavaScript. That something is really nothing because it's basically a bunch of special cases added into the code that make it look like there's some magical location at 0x0005,
Right.
which stores some magical value, but it never does because you know, whenever you try to access that location, there's a special case that says, oh, you're trying to access that location, therefore the engine will behave as if you had just accessed that location and returned a JavaScript value that is the integer 5.
Right, but you've consumed virtual address space.
No,
at the very least. Because
no, you haven't, because the 5 isn't really pointing at anything. There is no reserved space at 0x the 5. There is nothing there.
But if I have say I'm 32-bit and I have 2 to 32 2 of the 32 possible pointer values.
Yeah.
I've reserved some number of those that can never be used. So
yeah, that's right.
Right, like you have consumed, you have, you know, of your smaller address space, if you've got a small address space, you've potentially consumed some of that up front. But that doesn't matter in this case because it's not something that the user does that consumes that.
Right.
It just always is the case, right?
Yeah, and okay, I'm not sure if JavaScript sort of breaks the you know, the ECMA spec by not being able to create as large numbers as the ECMA spec JavaScript is supposed to be able to create. I'm not sure if they break that part of the spec or if they comply with that part of the spec. But the bottom line is, yes, there are, you know, there are some numbers you might not be able to express. But basically, you know, they solve things with pointer arithmetic at that point, you know. So I know that a JavaScript value has like I think the top level bit tells you whether it's a primitive or not, and so forth. And so you know, if the top level bit is set, then it behaves like a pointer, and if the top level bit is not set, then it behaves like a primitive value. They have like this sort of structure. So it's basically a bit field. In
which case, yeah, okay. The max safe integer is 2 to the 53 in JavaScript. So as long as you're like in a 32-bit system, that approach in JavaScript could be an issue, I think.
Yeah, probably.
They are actually only storing very small integers for the byte value, and like say large integers and doubles. They are still referencing storing the actual value in some place they are managing. So
okay, so and they have a cutoff.
Right.
Yeah.
So that I'm sure that's what V8 does too in some sense. But then how does that, you know, if you try and make a reference to one of those larger things?
Well, that's actually the classical case.
Right. Then it's no longer like, I think you were saying it's not an issue because it does this by value thing, but it doesn't do it by value for all numbers. And you
no,
know.
that's right. Yeah. And for those that it doesn't do it by value for, then the NAPI value or Jerry value or whatever is an actual pointer to an actual memory location. And so, you know, the whole referencing and weak reference and weak callback and all that stuff actually works. Right, but if it's an NAPI value or a Jerry value to a small integer, then everything still works. It's just that the weak callback will never be called because nobody keeps track of how many number 5s there are in the engine.
Right, and there's no guarantee that a weak reference will ever be collected, so that's okay.
Yeah, but I mean, we are already presenting the caveat that, you know, yes, the weak callback may or may not be called. It's up to the engine.
Right, that's what I mean by by spec. I'm saying that's just fine because
yeah, exactly. So yeah, I think we're covered.
So, but it sounds like if we go back to this proposal, like other than symbol, it seems fine, except that with the additional suggestion, you're saying maybe we should just relax that restriction
in
as
core.
long as the rest, in core, as long as the rest of the the engines.
Yeah, because think about it.
Can
If
support
we,
that.
yeah, exactly. Because like think about it. If we marshal, right? If we choose the marshaling approach, then for all the types that we marshal, we cannot have weak references, right? Because we are not a JavaScript engine. We don't know when a certain value goes out of scope, right? Because we haven't kept a reference to it internally. So we would not be able to support weak references to any of these errors. Whereas if we
like I think it would be that the error would have a strong reference to the C side, right?
Well, yeah, I suppose if we did the reference counting ourselves and we started dabbling in garbage collection, then yes.
But I don't think we need to do any of that. I think it's just that we marshal them and we associate them with the exception, right? So they don't need to individually be weak or not weak. They just need to be freed when the thing that was thrown. I guess maybe that's not the case.
Well,
like that was my original question, is like, how do we free those once they're no longer needed?
Right. Yeah, that's
because you can't throw a weak primitive, right? Like you throw a primitive, we would marshal it. We would basically say, okay, well, we can get the native value, right? And we now need to store it somewhere.
Yeah. And we need to decide when to destroy that. Yeah.
Right.
I mean, look, we can we can sort of hack it. That's one thing. Is whenever somebody throws a primitive value, right? We create a wait, never mind. Don't
want to create the object.
yeah, you can't create the object. Yeah, so it's basically. I mean, I'm sure there's a solution for when to destroy it. I mean, at worst, you just hook up you just create a cleanup hook. And you store these things on the linked list, and then you just walk down the list and destroy them all at the cleanup hook. At the very latest, there might be opportunities to destroy them sooner. We just have to.
But I think we want a way to destroy them. Like you don't want to say throw exception, and then every time you're doing that, you're leaking some memory.
But in a, let's say, massive production environment, there might be, let's say, massive reference to primitive values if we are allowing them. So that will act like a memory leak until the whole environment is teared down. If the weak finalizer is never called for the reference.
Right. So
well, like
honestly, it sounds to me like this is a problem that the engine has already solved for us. Every engine has solved this problem for us except Chakra Core, right?
So that may be the right thing, is to just sniff test the others to make sure that if that's the case, then maybe that's the thing we should do.
Yeah. Yeah, and you know, honestly, we always make an effort to pave over differences between engines, right? Like we're basically the jQuery of JavaScript engine native APIs, right? But there is only so much we can do. If an engine comes along tomorrow that doesn't support this, well, we're like, okay, well, sorry, every other engine supports this, so step up to the plate.
So it's that part is the keeping it to a reasonable set of requirements, right?
Yeah.
So do we expect most engines to? If all of them from the current existing ones do, then I think we could say it's a reasonable expectation, especially since Chakra Core doesn't really exist anymore, right? So
exactly.
And it may have just been a point in time thing where they could have done it, but anyway, I think checking those other ones makes sense. Just so that we don't, we're sure on that front, and then that might be a good suggestion. I'd suggest we take the discussion back to GitHub at this point, since we've used most of the time.
Yeah.
Does that make sense?
And, and I think we have a good sort of way forward, which is to check the docs.
Okay, tracking issue for modules. I don't see anything new there, and we don't have a huge amount of time, so I'll just move on. I haven't enabled debug testing for add-ons. So now I think all that's left is looking at issues raised by module owners. This is way out of date though, so let's just look at. First of all, are there any that people want to bring up?
On Node add-on API, I started work on wrapping the pull request for wrapping the node API for add cleanup hook, the first one.
Okay.
The test is failing just because of line endings or whatnot. So this one, because this has existed since like version 3, but I guess we've
Yep.
never wrapped it. I don't know
Yep.
why. But if we go to the, I guess the napi.h file in file
In
change,
here?
yeah.
Okay. Come on.
Or yeah,
This one or higher?
yeah, and then
Yeah,
just
okay.
scroll down a bit.
This one.
Yeah. So basically what the API, the C API allows you to do is to add the hook and remove the hook, right? But in order to remove the hook, you have to pass the same function pointer and hint argument because it's that same pair, right? So in order to do that, we had to store that data wrapper that we make, and in order to allow lambdas and stuff being used, we sort of wrap what the user provides into a wrapper so that we can pass it to the right underlying C call, right? So this cleanup data here is sort of that pair of what the user originally provided as their callback, if that sort of makes sense. And the question that I mainly have is, I had to put this there because there's these the wrappers. If you're it's similar to how with the thread safe functions we have static wrappers that we pass to the underlying native C functions. And in my comment, if you click that link, I think it'll just take you to that.
This one?
Mm-hmm.
So click to that. Okay. Yeah.
Yeah. So these are like the static functions that we pass to the underlying NAPI create or add cleanup hook and whatnot. So the reason why I have that cleanup data being public is because it has to be typecast here on line 341 and 348. So just sort of looking for some thoughts about that, if anyone has some time. Then like the test I have at the bottom is sort of, I think the tests are at the bottom, I can't remember. All right,
wait a
so,
minute. Wait a second. The static cleanup hook,
yep.
right? That you end up passing into core. Is that part of a class, or is that just a standalone static cleanup hook?
It's in the inline file inside that details namespace.
Okay. So then I think the way you want to do it is that the thing you pass to core is a static member function of the same class that has the pointer. And then the pointer can be private because a static member function of any given class has access to all the private data inside that class, as long as the pointer is cast to an instance of that class. So if class X has method static Y, and static Y accepts a pointer of type X, then inside the implementation of static method Y, you can access the private members of the pointer. As long, so you know what I mean? Like the static method Y has to be a class method, and then you can make everything private.
Okay, so then what would end up happening is those wrappers would have to be removed from details and then put into the napi.h class inside
Yeah,
cleanup hook or
yeah,
something. And
yeah,
then,
exactly. Yeah.
okay, and then that could be, well, then those would have to be public though, because then the add cleanup hook on 207 needs to access it.
Well, then add a method to the class, a public method to the class, which, you know, does the right thing. It may just be an access, or you may just say, you know, the implementation of add cleanup hook is such that it creates a new instance of class cleanup hook and then calls the method, you know, add, and that's it. And then, you know what I mean? So basically you turn your public API into a single private API call, which is an instance method call on a newly created instance. And then all the code that actually calls into an API is inside the instance method of your class.
Yeah,
which is public, but what it does is private.
right. I guess that's sort of what I kind of already did a little bit, but maybe I can extend it a bit. If you scroll to the inline file now, I guess that's up. Yeah. So the this add cleanup hook here returned this cleanup hook instance. And then that cleanup hook instance has the constructor on line 5732, which does all of the underlying NAPI calls. So I just have to kind of extend that, restructure that a bit to figure out.
Yeah, basically, if you moved everything, if you moved everything below the return statement, or return cleanup hook. Okay, hold on. What's going on here? Oh, you have two different overloads of add cleanup hook. It looks like. Oh, because one is with a hint, one is without a hint. Yeah. Okay. Yeah, exactly. Yeah, that's So the NAPI call is here. Yeah, this is good. Okay, then. But what do you pass it? Env. Right. So this void star wrapper, that is the users. Yeah, okay, so don't pass the user's wrapper in there.
Or no, that void wrapper is the details wrapper.
Oh, okay,
whether it's the wrapper with hint or not, because
okay.
Because that goes to the cleanup hook's private data, so that when you call remove, we can remove it.
Yeah. So basically, the NAPI add-env cleanup hook call should be happening inside the class that stores the user data, and then you can make everything private, right? So it has to happen. Yeah, that's what it has to happen.
Okay.
So wrapper here can be like cleanup hook : cleanup hook wrapper, right?
Yeah.
Yeah. So there, and that's it then.
Okay. Yeah, that makes sense then. So then I'm just also looking to see if I can also tweak it to work also with the async cleanup hooks, or if the API will be too different. And
the API is slightly different, because in the case of the async cleanup hook, if I remember correctly, you have like a token that you receive when you add the hook, and then you give a token. You don't give this. I mean, conceptually it is the same API, but implementation wise, in one case you do have this token, and in the other case the token is the function and the pointer itself.
Right. Okay. Well, that's all that I really wanted to discuss for the issues that I had.
Okay, we only have 4 minutes left, so we maybe have time for one more thing if there's something somebody wants to.
I would like to leave this last bit of time to talk to the mentees to see if they have anything going on with them.
That sounds like a good plan.
Yeah, so sorry, so like I have like that PR up, like for the symbols for a while now. So I made some changes based on the feedbacks. I'm just wondering if you guys can like take a look at it again.
Which number is that?
That is I think on the Node add-on API repo 972.
Right, so this one.
Oh, right. I had an objection to that. Let me see if it was addressed. What was my objection again? All right, let's see here. Oh, the null. Yeah, I checked. Okay, yeah. Okay. Right. Okay, so yeah, so did you take out the part about accepting null? Because you can't.
I'm not sure. Like, do we add a check before pass it into the method?
Yeah, hold on. Where the heck was it? Okay, blocking until we figure out what happens when you pass null to an API create string. Yeah. So okay, so basically bad things happen when you pass null to an API create string UTF-8, or they used to, right? They don't anymore because I landed a thing that will refuse to create a string if you pass in a null pointer as the car star. But that change does not save us from having to do the same check here, and in fact aligning the return value with whatever's happening in core, because the change in core hasn't yet percolated throughout all the accepted versions, right? And so we must sort of do double the work here. We have to add a null check, make sure that the const car star or standard string cannot, well, I don't know, it can't be null. But the override or the overload that you have that accepts a const car star must not accept the null. It must what must it do? It must basically throw an exception of type NAPI invalid value if you pass in a null pointer const car star. So that is a change that you must make so as to align with the behavior upstream. And so, yes, we're basically making the same change that's already upstream, but for the purposes of release management and all that, it's easier to just make the change twice than it is to wait for that change to basically work for you.
Okay, so I just I guess I'll like throw an exception if a null pointer is like passed in.
Yeah. Look at what, like we say in a bunch of places in Node add-on API's implementation, we have something like return or throw something if failed, right?
Okay.
So and usually we say an API status equals, make this an API call and then throw if failed, and then you pass the status, right? And that's a macro that will throw something if the status is not an API okay, right? So in this case, in your implementation, what you will say is, if the const car star that was passed in is null pointer, then don't even call the NAPI. Don't wait for it to return a status, but rather immediately throw with NAPI invalid arg. So use that same macro to throw with NAPI invalid arg, and then that macro is implemented differently depending on whether you have exceptions on or not. But basically, that's sort of the flow there.
So I have a question though about checking if values are null within our wrapper. So for example, we don't check in like string new if they pass a null pointer there, do we?
No, and we should. Yeah, we should. Yeah, so yeah, this might just be a second PR.
Yeah, I was going to say, I think this is adding tests.
Yeah.
So maybe it's worth like stripping out we're missing checks from the PR itself.
So
yeah, okay,
where it's possible to have a null pointer, we should know that if it's a null pointer, we have to do an exception check in our code if the user passes the null pointer. Okay.
Yeah.
Instead of having the engine return an error code saying like invalid value because we want to have the check first.
Oh yeah.
I think
okay.
it's like in this, it's like there was a missing check in the core API, which Gabriel's added, but because that'll take a while to percolate through the releases, we should just add an additional check, which, you know, at some point in the future we could remove.
Yeah,
Okay.
yeah. So basically, the check, looking at the PR, the check needs to be made in string new, like in the const carstar version of string new, because then that will also cover this symbol 4, because symbol 4 calls string new here at some point. Where is it again? Bum 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 bum.
Right. So then.
Yeah, string new. So it calls it in a bunch of places.
Right.
Yeah, so basically symbol 4, standard string description just calls string new, and then symbol 4, the NAPI string. And so if we add the check to string new, then we will cover all of this code. But that check has to be added first.
Right. Okay. All right. That makes sense. Then one thing also, maybe if you continue scrolling down a little bit to the symbol 4, on line 545, we might as well remove that default equals null pointer since
For sure, absolutely, yes.
Yeah.
It must not be null pointer.
Got that one, Jack?
Yeah, for sure.
Okay, I have to actually drop off, but I could make somebody else the chair. And I'm also on holiday next Friday, so Gabriel, can you chair next week?
Yeah, I'll do it. Yep.
Okay, so thanks. I'm just gonna pick somebody.
I can chair.
Okay, I will make you, so panelist, Kevin, you will be the chair.
Okay.
Or either of you can talk about who's gonna chair next week, but I'm gonna make you the host for now, Kevin.
Okay.
So
all right,
you can share whatever. Talk to y'all later. Thanks.
Yeah, talk to you later.
Bye.
Bye.
All right. Well, I really had nothing else to talk about, and Deepak already had left. I was going to see if he needed to talk about anything. But does anyone else have anything to talk about?
So just to wrap it up with Jack. So do you think you can make that change in string new in the const carstar version? Because it's really just like a 2-line change in string new, and then we're good to go. Okay,
so I guess like I'll make a change in string new. I'll check if I get a null pointer, throw an error, and then from I don't make any changes from symbol 4 apart from removing the default args. Okay.
Yeah. That's it. Those are the 2 things, and we're golden.
Okay, thank you so much, guys.
Yep. All right.
All right. Thanks.
Thanks, guys.
Bye. Have a good day.
Talk to you later. Bye.
Gabriel?
Yeah, what's up?
Oh, yeah, we have to talk about who will be doing the chair for next week. Gabriel, will you be able to do that?
Yeah. You know, if you want to chair, then you should ask to be added to the node.js YouTube administrators list, because you know, if you want to do live streaming, then you have to first log into that account so that the live stream gets added to that account. So that's like one step you need to do if you want to do like chairing permanently, and then you also need to have access to like the meetings thing. Like you have to install like a password manager, because we have like meeting passwords and that kind of thing. So, and I'm not sure. Yeah, Michael knows this stuff.
Yeah,
so just,
I can email Michael and be like, hey, I'm interested in host chairing next week. Can you help me with what I need to do for that? Yeah, okay. I think that works.
So meanwhile, I can chair, because I have that whole YouTube thing already set up. I can never live stream, because for some reason you can't live stream if you're using the web client, and the native client doesn't work for me. But at least I can record and then upload to the YouTube channel later. So it's kind of a ugly fallback, but at least I have it.
Gotcha. Okay. Then the GenTCast, did you have anything else?
Yeah, I just a quick heads up. So we have the sys testing for the V8 reference and the maybe type in the node add-on API. We are waiting for Gabriel's review to move on to the next steps. Like say we testing the NAPI buffers, so on.
Got a link for me?
Yeah, I can share the link. I posted it on the chat.
Okay.
So if you have time, please take a look so that we can move on to the follow actions. Many thanks. And that's it. And I don't have any other topics.
Yeah, sorry, I've been kind of busy. I'll try to find some time. Thanks for the link.
Yeah, take your time.
Okay. All right,
Many
cool.
thanks.
All right,
Yeah.
then. I'll talk to you guys next week.
Yep, talk to you later.
Talk to you later.